Okay, good evening. It's Professor David J. De Los Reyes. Okay, the date for today is November 13, 2023, and the time is what time is it? 10:16 p.m. Okay, my topic for tonight will be a continuation of my trigonometry topic, and I am now on lesson number 22, trigonometry. So for tonight, we will be discussing again trigonometry, a continuation. And the topic for tonight is one of the foundations of trigonometry. Without knowing this, you'll get a problem on the higher up mathematics. Okay, let's proceed. The title for tonight will be Trigonometry, lesson number 22, and the title of the topic is Trigonometric Identities of One Angle. One angle. Because there are the so-called other angles which are double angle. That's another story. But for tonight, we will be deriving the foundation of trigonometric identities involving one angle. Okay, let's try to derive the three most popular identity under the study of trigonometry. That is, I will give you number one. Sine square of alpha plus cosine square of alpha, and this should be equal to 1. Okay. The next one is actually 1 plus cotangent square of alpha equal to cosecant square of alpha. Am I still on camera? And the third one for tonight, 1 plus tangent square of alpha will be equal to secant square of alpha. These three identities, when you go to the study of integral calculus, that is the so-called integration involving trigonometric functions, we needed these three here. So the importance of these three here is when you go integral calculus and the so-called integration involving powers of trigonometric functions, we will be using these three identities. Okay, let's try to bring out the so-called derivation of the three identities. Some of you are not interested in the so-called derivation, but if you could absorb the concept of deriving any formula, okay, I think it's better for us. Okay, so for tonight, we'll be deriving this identity here. This number 2, this number 3. Okay, let's proceed. We will be bringing out a right triangle like what we did under the study of angles, right? We are given a right triangle. We'll just need one angle for this, what do you call this, derivation. The other angles will still follow this concept of identity, but for tonight, we'll just concentrate on angle alpha. This one. This acute angle is alpha. Its opposite side is side A. This should be hypotenuse C, and this is the so-called adjacent side B. So to derive this one, we will be deriving this identity here coming from here. So the foundation of this is actually our knowledge of the so-called definition of the different trigonometric functions involving a right triangle. Okay, using Pythagoras principle, this angle here is 90 degrees, so the opposite side and the adjacent side are actually perpendicular with respect to each other. And under the study of Pythagoras, the square of the hypotenuse should be equal to the sum of the square of the opposite side plus the square of the adjacent side. That is A quantity square plus B quantity square equal to C square. It should be something like this, right? We put an open and closed quantity, so it looks proportional. Okay? So A quantity square will be A square and b quantity square will be b square, and this should be equal to c quantity square is just c square. So to derive the first one, okay, we'll try to multiply the given equation, the resulting equation, by 1 over c square. Or it seems we divide all terms by c square, or to say it in another way, we'll just multiply the given equation, the resulting equation, by 1 over c square. It is the same as dividing all the terms by c square, right? So if we try to expand this one, we will try to distribute this 1 over c square individually. It will become a square. A square times 1 over c square will be a square over c square. And b square times 1 over c square is b square over c square. And this should be equal to, for the right hand side, it will be a c square over c square. Okay? Okay, let's try to, actually this cancels. But there's the proper way how to cancel this one. So for those of you who are fond of cancelling from the numerator and denominator, it is just something like this. A product of c times c over c times c, right? Okay. I put this under the short videos that to cancel some terms on both the numerator and denominator, the operation should be multiplication, okay? That's the only way the time we could cancel. So a c times c will be c square, and c times c will be c square. So actually the operation is multiplication, the operation is multiplication. So we could cancel, right? This is 1, it's 1, it's 1, 1. 1 times 1 is equal to 1, and 1 times 1 is 1, and 1 over 1 is actually equal to 1, or c square over c square, okay? Expedited solution, this should be equal to 1. So the right hand side is 1. Okay? I am just telling the errors on this sort of cancellation. So we divide c square by c square. We could divide it because the operation on both the numerator and denominator is multiplication. The requirement is the operation should be multiplication. If there is a plus sign or a minus sign, okay, whichever numerator or denominator, you cannot cancel. Oh, what's next? So this will now become the first one. We use our knowledge of the so-called laws of exponent. That is, the power here is 2, the power here is 2. So we'll just take the ratio a over b under same power 2, right? Because a over c quantity square is actually, if we try to expand this one, it is actually a square plus c square. So we could rewrite the first one as a over c quantity square. And the second one, still, the powers are 2 for both the numerator and denominator. So we will just take the ratio b over c quantity square, and this should be equal to 1. Right? And from the right triangle, the ratio of the opposite side over the hypotenuse is actually sine of alpha. The ratio of this side here over hypotenuse is the sine of angle alpha. And the ratio b over c, adjacent over hypotenuse considering alpha, it is actually cosine of alpha. Right? So we will now substitute the value a over c and b over c back here. So a over c is actually sine of alpha quantity square. The ratio b over c is actually cosine of alpha. This is quantity square, and this should be equal to 1. If we try to simplify this one, the proper way on how to write it will be sine square of alpha plus cosine square of alpha is equal to 1. This is the number 1 trigonometric identity under the study of so-called trigonometry. Okay, whether you are sleeping or swimming maybe, or you are outside, don't try to forget this one. Sine square of alpha plus cosine square of alpha is equal to 1. Sine square of alpha is actually the product of sine of alpha times sine of alpha. And if we try to multiply this one, the proper way how to expand this one or simplify this one is it will just be simply sine square of alpha. It is not sine square of alpha like that. This is wrong, right? It should be sine square of alpha, meaning it is the product of sine of alpha and sine of alpha. So the expansion of this one, or the simplification of this one, will be sine square of alpha plus cosine of square of alpha is equal to 1. Okay? What will be the next formula? That is 1 plus cotangent. Why we arrive at this formula here? Actually, it emanates from here. Okay? To derive this one, okay, I will go back here. Okay? This resulting identity number 1, we will multiply it by 1 over sine square of alpha. Okay? So the common factor 1 over sine square of alpha, open bracket, sine square of alpha, cosine square of alpha equal to 1, close bracket. And if we try to expand this one or distribute the sine square of alpha, 1 over sine square of alpha times sine square of alpha is actually sine square of alpha over sine square of alpha. 1 over sine square times cosine square will be cosine square of alpha over sine square of alpha. And this should be equal to 1 times 1 over sine square is just 1 over sine square of alpha. And in here, the simplification of this is 1. Or you could, the proper way to cancel it, it should be something like this. You try to put sine square of alpha as the product of sine of alpha and sine of alpha. Right? And for the bottom portion, it will still be sine of alpha times sine of alpha. Okay, the operation is multiplication. We can cancel, right? This will be 1, this 1, so this is actually 1. So sine square of alpha over sine square of alpha is actually 1. Okay, this is with the power 2, this is with the power 2, so it could be simplified as simply cosine of alpha over sine of alpha close quantity square. Their power is common, right? And for the right hand side, it can be written as 1 over sine of alpha quantity square. Okay? 1 square is just 1, and sine square alpha square is just sine square of alpha. So we could also, combine 1 over sine of alpha under the quantity square. Anyway, 1 square is just 1. It doesn't hurt, right? But from our previous definition of trigonometric functions, okay, cotangent of alpha is the ratio cosine alpha over sine of alpha, right? Okay, we know this one from our previous discussion. And cosecant of alpha is actually the reciprocal of sine. That is 1 over sine of alpha, right? Right? So what will be next? If we try to follow this, it will become 1. Am I still on camera? Okay, 1. This will be 1. I will replace cosine over sine by cotangent. Plus 1 cotangent of alpha quantity square, right? And for the right hand side, 1 over sine is actually cosecant. So this will become cosecant of alpha quantity square. So if we try to simplify this one, it will become 1 plus cotangent of alpha to the second power is cotangent square of alpha. And cosecant of alpha to the second power will be cosecant square of alpha. And this is actually our identity number 2. 1 plus cotangent square of alpha is actually cosecant square of alpha. Okay, that's number 2. We needed this under this study of what we call this integral calculus, that is in the evaluation of the so-called integration involving trigonometric functions. Okay, the last one for tonight. We will be deriving this one. That is 1 plus tangent square of alpha is secant square of alpha. Actually, this one here also emanates from this. Or you can still use this one, but I want to continue with this one. We will multiply this identity number 2 by the value 1 cotangent square of alpha. Okay? Am I still in camera? So 1 over cotangent square of alpha, open bracket, this is 1. Cotangent square of alpha equal to cosecant square of alpha, close bracket. Okay, distributing 1 over cotangent square times 1 is 1 plus cotangent square of alpha. Okay, this one here, it will become cotangent square of alpha over cotangent square of alpha. This will be 1. And the right hand side will be cosecant square over cotangent square, or it will be cosecant over cotangent quantity square. Okay? Just take note of this one. What is tangent? Tangent is the reciprocal of cotangent, right? Right? Tangent is actually 1 over cotangent. And what is cotangent? Cotangent is cosine over sine, right? So if we try to place this value here, this value here and this value in here, what will come out? 1 over cotangent, okay, it will become tangent. Because tangent is actually 1 over cotangent. So we could replace 1 over cotangent by tangent of alpha. This is quantity square. This one. Right? This is 1. And for the right hand side, it will be, I will just follow this. Cosecant of alpha, I will maintain cosecant of alpha. Then I will replace cotangent of alpha by the ratio cosine over sine of alpha quantity square. Okay? So this will now be 1. I write this one first, plus this, tangent square of alpha, equal to. I will now change the operation from division to multiplication. So I will rewrite the numerator, which is cosecant alpha over 1 quantity square. This is square. Times. I will invert the resulting denominator to change the operation from division to multiplication. So this will go up. Sine of alpha will go up. Cosine of alpha is down. Quantity square. Okay? And if we try to simplify the right hand side, the simplification will be this. I will rewrite cosecant square of alpha, right? Sine square of alpha can be written as 1 over cosecant square of alpha. So the square of sine of alpha quantity square is sine square of alpha. And I will replace that by 1 over cosecant square of alpha. Right? Right? What is cosine? This cosine here, the cosine is underneath, right? So this is 1 over cosine square of alpha. So actually, this cosecant square of alpha cancel with this. The operation is all multiplication, so we can cancel this. So what remains is 1 over cosine square of alpha, but 1 over cosine of alpha is actually secant of alpha, right? But this is square. Therefore, 1 over cosine square of alpha is actually secant square of alpha. So the simplification of the right hand side is just simply secant square of alpha. So the third most important trigonometric identity under the study of trigonometry, that is 1 plus tangent square of alpha, will be equal to secant square of alpha. That's it. Okay, guys? At least we now know the 3 most important trigonometric identities under the study of trigonometry. That is sine square of any given angle is equal to sine square of angle alpha plus cosine square of angle alpha is equal to 1. The second one is 1 plus cotangent is actually cosecant square. And the third one is actually 1 plus tangent square of alpha equal to secant square of alpha. And what's the significance of this? We will be needing this one in the so-called study of integral calculus, that is in the so-called integration involving trigonometric functions. Okay. Good evening from Los Angeles, Professor Identities.